set coefficients to 0. Setting a coefficient to 0 is saying ignore that column. So it's giving me an incentive to say, instead of just putting weights on everything, be selective about what I put weights on. Try to set most of your weights to 0. So I'm only selecting the important columns that are non-zero coefficients. So this is a good idea, but it needs some adjusting. So first of all, this is the lasso term. And we said we're penalizing non-zero coefficients. To encourage it to ignore non-useful columns. So I want to do a good job predicting, but I also want to encourage the optimization to not use columns that would help the predictions, but not so much. The thing is, what units are these in? Square dollars, square test score points? What units are these in? Test score points per dollar teacher salary. They're in all kinds of crazy units, right? So they're not even comparable. It doesn't even make sense to add them up. So in particular, at least all the residuals are in the same units, like dollars or square dollars now. So I need something to say how important is this term versus how important is that term. So I can put some kind of coefficient here, or we could call it a weight. It's the weight on the lasso term, which is also called the regularizing term. And some books use lambda, some use C. That's the nice thing about standards. You can choose from all the different standards. Okay, so if you really want to do a good job throwing away junk columns, you set a big value there. If you want to do a moderate job, you set it small. If you set it to 0, then you're back to ordinary regression.
Is that arbitrary to set the C value?
So we're in the College of Arts and Sciences, right? That's an art, is setting the C value. And there's some guidance on how to do that.
Okay.
But we'll talk about that later. So this is called lasso. It's also called regularizing or regularization. So lasso is also called L1 regularization. And like we just said, we're doing the sum of the absolute coefficients. Could I raise that to the 1 without changing it? Okay. There's another thing called ridge regression, which is called L2 regularization. And there, instead of summing the absolute values, I'll give you a hint. There's a 2 instead of a 1. You're squaring each coefficient. Spark has options to do either one or both. I think you can do both at the same time. Both is called elastic net.
How come you get this name?
Elastic net?
Yeah.
I'm not sure. I know where the ridge one comes from, but it takes 5 minutes to explain.
It's in Spark?
So Spark can do either one of those. Historically, people like doing ridge because the calculus is easier.
Okay.
But in big data, we're actually not doing calculus all that much. We're just making quick and dirty approximations. And so we can do that for either one of these or both combined. Now I'll leave you with a mystery for the weekend. we said this is in like dollars and this is in dollars per something, or test score points squared and test score points per percent free lunch. This C can't account for all of those, right? It might convert one of the units successfully, but it can't simultaneously convert test score points per dollar and test score points per percent free lunch. So adding these together actually doesn't make sense at this point. So we need to figure out how to make all the coefficients in the same units. So hopefully there will be a next time. All right, we're out of time for today. So here's an idea. If you're looking for a project, just create a bunch of junk columns in Spark, plus like 2 or 3 columns that actually do help predict the Y value. And then try running this stuff and see if Spark will actually select the columns that you know are useful in predicting the Y value.
So it's going to tell you which columns it's selected, and then the R value or something?
So it'll tell you some measure of how well the fitting went. It'll give you back the list of coefficients, and the ones that are 0 are ones that it did not select. All right. By the way, you can email me any questions you have